All right. Good morning, everyone. In the interest of time, we're going to go ahead and get started. We've got a lot of content and great speakers coming to talk to us about what we've been sort of kicking around and ideating around, which we're calling the Florida lifelong learning model. This town hall is meant to first make everyone aware in the college that we are ideating around what does lifelong learning look like in engineering. And to start that conversation, we sort of looked at a model that would think about 3 phases or 4 phases of an engineer's life. And that's the budding, the novice, the agentic, and lifelong learning engineers, the name we're going to call each of these phases now. But to bring that to life, I've invited several speakers that are noted here on this initial slide to give you an idea about maybe a little bit about what we're doing in each phase. Why are we really having this town hall? I would say that I've got at least 2 objectives, and that is, number one, to let everyone in the college know that we have been thinking about learning across an engineer's life. And number 2, that with the guest speakers, helping you understand a few things that we're doing in each of these stages would help you maybe inspire some idea and thought around things that you might like to connect to in terms of maybe these specific speakers or some of the activities that they're speaking about. If I had to sort of top of mind think about a third, it might inspire you to sort of say, hey, in that phase, are you thinking about this or that or adding this thought? And I'm happy to receive any of those thoughts or anything else that you might have as a result of participating in this town hall, whether you're watching it live or you're watching it as a recording. One of the deliverables as a result of this town hall, once the Zoom link is available for it, I will make that available to everyone in the college, along with the slides for each of the speakers. So with that, I'd like to first start with, what is this first phase that we ideated called the budding engineer? So I want to first think about the lifelong learning model as a whole. So just straight out of our minds and thinking, and I'll sort of slide over to the end here. You see at the bottom of the slide that credited with this thought is Adalis, myself, and Forrest. But, we started thinking about this in the spring, but now here is an opportunity for everybody to sort of look and give some sort of input. The slide has quite a bit, and I would hope it's not your first time seeing the slide, but at the top of the slide, if we read it from left to right, thinking about it as rows, the stage is what we will sort of tick through this morning, starting first with the budding engineer, the novice engineer, agentic, and lifelong engineer. You'll see in that stage, we've sort of identified the budding engineer as sort of that K through 12 period. The novice engineer being the undergraduate phase. The agentic engineer, you'll see, is sort of noted as maybe someone who's going through graduate education, maybe postdoc fellowship. It's also the early years of an engineer's career. And then lifelong learning is what we might consider maybe mid-phase engineer all the way through retirement, right? We have ideated goals, if we think about that as the next row of information. But this was sort of just our initial thinking about goals. And then programs, that last row. Now, across the program row, you may say, hey, I see some things. Are we doing those or aren't we doing those? So some in this row, we are actually doing. And you'll hear some of our speakers speak about those. There are some things that we want to enable to be done. And I want to focus maybe my thoughts a little bit on that in this introduction. If we see here in the row for programs and under the column for novice engineer, particularly, we see some dark blue sort of fields here. And then we see some arrows sort of zigzagging. What this is meant to sort of put in our minds and thinking is we want to enable over the career or lifelong learning of an engineer, their ability to sort of flow with their life and gain education along the way. So we think sometimes about an undergraduate engineer who starts with us in the first year, continues with no stoppage all the way through graduation. And that's one path. But there's multiple other paths that learners take along the way that might have them stopping out for reasons of family reasons, for military service, or other things. We want to enable in our educational offerings to rise up to meet those needs. You'll hear me talking about in your departments about this idea of how do we do that? How do we offer maybe the way that we teach students in a different way, maybe the modalities that we use could be one way to enable this pathway, and any other sort of ideas that we have. You'll see represented here on the slide is this idea of what we've been talking about is this remote PhD program as well. So this idea of how do we serve, yes, well, continuously, our campus-based programs. This is certainly not ever that I think going away. However, we would be not forward-looking if we didn't realize that learners today want flexibility. And how are we going to remain, and I don't want to say relevant, but how do we remain in an area where we're thinking about serving our learners in these flexible modalities? So that's the introduction that I wanted to give to the model. And I really want to now hand over the speaking time to our first pair of speakers who will talk to us a bit about the budding engineer. We have with us Christina Gardner-McClune from computer science and Nancy Rizicki from material science. So without further ado, I'd like to now pass on to my colleagues so that they can speak to you about the budding engineer. And sorry, I didn't stop sharing. So in this budding engineer, one of the things that they are focusing on is that K through 12 experience. So Christina and Nancy, I'll hand over to the two of you. And thank you for joining us.
Yeah, and I'd like to thank everyone for joining us today. And so thanks everyone who's participating live, and thank you everyone who's watching through the video. So what we want to start out talking about is what the ecosystem looks like within our state, or what the landscape looks like within our state. And we were going to break it into student programs and teacher programs, because when we think about the budding engineer, we think about how we're serving the students in our state, but also how we can serve more students by serving the teachers in the state. And as the preeminence land-grant institution, we should be serving all of the students and teachers in the state of Florida. So how do we do that? We do that through our interactions between faculty, industry, our grant work, and things within the college. So what does the existing landscape look like at the University of Florida? So what we have at the university level is that we have CPET, and CPET is the Center for Pre-College Experiences, and they have some programs that they share with the College of Engineering. Additionally, the university provides, which is a wonderful addition, a whole youth compliance department, and that's been very, very important in working with students across the state of Florida. So what do faculty offer? Faculty have some student summer experiences. There are some within the departments, some within individual PI grants. There's some camps, there's workshops, there's one-day programs. And then when faculty write career proposals and broader impact proposals that intersect with the grant world, they're often thinking about how they can bring things down to a student level for their research work. And so faculty have done quite a bit of broader impact with students across the state of Florida. Within the faculty and industry connection, we have student contests. For example, we just finished having an AI contest sponsored by Duke Energy for high school students here at the University of Florida, where students designed an AI solution to an energy grid problem resulting from some type of natural disaster. Additionally, we have industry intersection with our student professional organizations, where our student professional organizations provide an enormous amount of outreach to students, both within the Alachua County area and more broadly around the state. Additionally, we have college programs. And some of these college programs are active, some are retired, but could be active again, but they've been developed. We have E-Week, on which students come to campus and student groups and student orgs present. We have college tours that are put on by the engineering ambassadors. We have SECME, which is the Southeast Regional Minority Consortium for Engineering, and that was brought to the University of Florida a few years ago. We have the EFTP program, which was a transitional program for students entering the University of Florida as freshmen. And then we have the Step Up program, which is for maybe a different type of student transition program for students entering the university. And then finally, what we currently have in place are things around student curriculum through grants, most notably the grants that we've received to do the AI curriculum and the data science curriculum for the career and technical education courses in the state. So that's what exists now for the student level. And Dr. Gardner-McCune is going to do sort of a talk through after we go through everything. But here's some things that we haven't thought about that we may want to be thinking about as we talk about how we can build out our K-12 presence in the state of Florida. So, you know, if Duke Energy is willing to help pay for student contests, what other industries are willing to help pay for curriculum that's being developed by faculty? And this could align also with career proposals and broader impact. How do we bring students to the university, or more broadly, bring faculty to the students? And we could do that through studio presentations. There's a beautiful studio lab in the Herbert Wertheim building where faculty could do virtual presentations to students around the state regarding their research. We also need to have more alignment with centers and institutes to build student experiences across the whole entire college and being able to link all of those things together. We also need infrastructure. At present, there's no infrastructure to support all K-12 activities for students within the College of Engineering. And finally, faculty need templates and exemplars for broader impact and faculty engagement. We can't expect people to walk into the University of Florida and be ready to present a career proposal and understand the landscape.
Last time
I'm sorry, there's someone talking.
I think we have someone in the background. So also one thing we might want to think about is how do we provide professional development for faculty doing K-12 outreach? There's a lot of new compliance rules, and then how do we create engaging professional development for faculty to see how they can engage with students? And finally, we should be working together for identification of K-12 grant opportunities and support for district interactions at the college level. So then when we look at what we have for teachers within the state of Florida, we're a lot more limited in terms of what the college has been providing to teachers. So faculty, again, have career proposals. We've had a few RETs within the College of Engineering where teachers come in for the summer, but those have been few and far between. There is some work being done on teacher certification between faculty and industry. I know Dr. Gardner-McCune has been working on some of that. We have had several professional development grants for teachers to learn how to teach complex topics, including engineering, technology, materials engineering. So there's a lot of opportunity for grants to help provide support to teachers on teaching. And then there's the standards development, which was done by Dr. Gardner-McCune for AI and for our team for the data science. Now, what the university has, again, is CPET will offer some teacher workshops, and then biotility, which was actually written into legislation, is a UF branch that does teacher certification and training for biotechnology and bioengineering. But what are some opportunities? Faculty need some support for understanding Florida school structures and statutes. There are more than enough structures and statutes in place that are confusing to people who want to work in schools. Again, how do we offer industry externships, not just for teachers, but potentially also for faculty who could spend their summer perhaps working at Lockheed Martin and learning new techniques or industry relevant techniques that may be useful for both our undergraduates and for work in the K-12 arena. And then how do we create online masters? Not everyone can come to UF. Not everyone can take off to do a formal master's program. So how do we create online master's programs tied to critical certification needs within the state of Florida? And then how do we create more workforce development and workforce opportunities with industry and college for teachers and teacher certification? And then finally, we do not have a teacher-focused website for resources or to find out information related to what is here at the University of Florida. And again, we could be identifying and writing more RETs to bring teachers onto campus and having teacher symposiums. We held a teacher symposium last year around AI. We had over 100 teachers from the state of Florida attend. So how are we bringing teachers to the university to interact? And again, teacher certification exam development is an area of need. The current engineering exam for teachers was developed using industrial technology standards from the 1970s. And so there's a need for a better and more relevant teacher certification, especially for engineering. And finally, again, how do we align with centers and institute to build student and teacher experiences so that we can serve more people across the state? Okay, with that, I'm going to turn it over to Dr. Gardner-McCune, who will go ahead and go over her call to action.
Well, thank you, Nancy. Nancy, you really tried to lay out all the things that we have going on and the opportunities. This call to action is just kind of summarizing what do we need to actually do this. This is real work that takes a full-time director, program coordinators, and staff. So it's going to be a significant investment from the college to get started to be able to do this well. There are, exemplars across the Southeast in the country who are doing this really, really well that we can take some pointers from. But we have the opportunity to really create an engineering, K-12 pipeline across the state so that people come to us. We're not going to get all the students that we work with, but when people go, oh, they were a part of that, University of Florida program, it's going to give them a leg up for admissions into engineering programs across the country. It'll increase our stock. So we really need to be investing in establishing infrastructure here. Right now, it's all Nancy's doing a lot of work. I'm doing a lot of work. I know some of you here on this call and maybe listening have been doing a lot of this work, but we're not working together. There's no centralized point in the college for us to all get together, talk about what we're doing, so we don't have to duplicate effort, right? If Nancy's already bringing in teachers, I can say, hey, can I pair up with you? Can I have a day or can I have an hour of your PD to do this additional PD, right? So there's opportunities for us to be collaborating without having some kind of centralized group to be able to coordinate this. We're all kind of doing this one-off. And so I think that's something where we can really kind of coordinate. And I think as we saw that we do have some signature programs at the college level, it'd be great to have some signature programs on the K-12 level. I know when I was at Georgia Tech as a graduate student and a postdoc, we created some of those signature programs so that, parents knew every summer, Georgia Tech Seismic, Georgia Tech's Computer Science, College of Computing, they're going to be offering summer camps. What's available to my kids, right? And this is a great way for faculty and graduate students and undergrads to get involved. Can you go back one second? Sorry. As Nancy mentioned, we can support this through active grant writing, donations, and program fees. I know some of the Georgia Tech programs very well, that some of the, K-8 programs are heavily, funded by, parents wanting some place for their kids to go during the summer or during the breaks. And that kind of funded some of the high school programs where it's a little bit harder to get high school students to pay because high school students could be going off to get jobs and working. So how do we get them engaged? And we need to do some better tracking. Like, we're doing some really amazing work, but we don't have a centralized place for programmatic and longitudinal tracking of these programs. And as Nancy mentioned, there's a lot of ways that we can be collaborating with faculty and students, different offices here on campus, as well as leveraging existing statewide collaborative agreements with school districts and nonprofits, and continuing to invest in our relationship with the Florida Department of Education. And in some conversations we had last year at that AI symposium that Nancy mentioned, we could hear that community colleges are really wanting to see UF step up and say, hey, we need some AI training for our faculty and our staff, so that way we can, begin teaching AI courses. We don't have the credentials right now for our faculty to do that. We need you guys to help us do that. And so that's a really great opportunity for us to really be a leader in the state. And then an opportunity for us to really just, actively promote the work that we're doing in K-12, because we are all doing a lot of work. Whenever I talk to someone, I'm like, oh my God, I didn't even know you were doing that. And it's nice when it pops off on the website as like an article or a news event, but where's that long-term repository of curriculum resources and materials and stuff that's going on campus that Nancy spoke about. So that's kind of my call to action. I think we are really well positioned. We just need some infrastructure here. And part of that infrastructure is investing in leadership here. Next slide, please. Nancy, next slide. It might be delayed. All right, so what I want to do is really just open this up for conversation about, what kind of leadership do we want to take in the state, in the Southeast? What impacts do we want to have on shaping this engineering talent pipeline? What's currently going on that you know about, or things that we may have missed in our model, or what's happening, and what supports do you think people need? So I'll just kind of open it up. Those are kind of the questions. Feel free to unmute. This will be great to have like a nice dynamic discussion and not just read the chats.
Thank you, Nancy.
We really want to seek feedback on, things that we want the college to really be thinking about in terms of the K-12 arena.
Yeah, thank you, Nancy and Christina. This is time now. We've got several minutes here until we transition to the next topic. For these discussion points, please unmute yourself, or if you'd like, I'm also monitoring the chat.
I can jump in and tell everyone something that Curtis Taylor and I and Sophie Spratley, our partnership program associate director, have been working on for a while, that really focuses on partnerships with the state colleges in Florida. We already have the Gator Engineering at State College of Florida and the Gator Engineering at Santa Fe. Santa Fe has been very successful. The State College of Florida, less so. But we all know the frustrations when we're talking about K through 12 outreach. As you pointed out, we're not going to reach every student, and not every student's going to get into UF, but we're at the mercy of the centralized freshman admissions process, which follows the rules governed, by Tallahassee. And so we have almost zero say, really. In fact, I would say zero say in who gets into UF as a freshman. And so our conversations have been, how do we do a better job of kind of really working with students early on who are at these state colleges and help them get better prepared to transfer to UF. And so what we're looking at, and this is not ready to go yet, so this is not a program that is yet in place, but we want it to be in place. And that is basically a priority transfer program. The idea being, instead of waiting to see who has applied to UF and then been rejected by UF through freshman admissions, and then we reach out and say, hey, if you're interested, you could look at this Gator Engineering at State College or Santa Fe program, which really limits who we can invite, and they have to be invited while they're still in high school and all that stuff. This priority transfer program idea would allow us to physically be out at Santa Fe or State College of Florida, and maybe in the future other state colleges, meet with students one-on-one their first year, talk to those students, get to know them, focus on underrepresented groups, and talk to the students about what they're interested in, kind of work on helping to prepare them along the way. We'd have milestones in place such that if the student met those milestones, and by the way, by those, I don't mean something onerous. I mean things that they should be doing anyway, like getting a jump start on professional development, on leadership, looking for internships, even as going so far as making a 4-year plan while they're at the state college. If they meet the correct number of milestones, they would have priority transfer access. And I know Dr. Taylor's already spoken to the department chairs about this, such that, for example, right now, if a student wants to transfer to, say, mechanical or aerospace, they need a super high tracking GPA. We're talking almost straight A's in math and science, right? So they're turning away a lot of great students. I mean, they have to like a 3.85 in math and science to get into those as a transfer now. But the priority transfer program, the student might only have to have, and again, don't quote me on these numbers because this is a program in progress, maybe a 3.25 or a 3.5 along with those milestones. So it would allow us to pull in not just more talented students and to have a say in who those students are, but to reach them a lot earlier. So we're not able to go as far back as, the K through 12, but I do think this could be a really important step in allowing us to be more visible across the state of Florida eventually, and to, as I said, reach students that ordinarily we wouldn't be able to reach.
Thank you, Jana. And I really see this as a connective tissue from this stage to the next stage. So thank you for your comment. Anna?
Yes, hi, everyone. I don't think I know a ton of people on the call. I'm Ana Maria Porras, and I'm an assistant professor in biomedical engineering. And I came to UF having had a lot of experience with public engagement with science and STEM in general. So, and my lab has been working a lot with an organization in the Sarasota area called Unidos Now, and we do targeted outreach activities to this organization that works pretty much exclusively with Latina families, and a lot of the kids in their program, it's not affiliated with a school district, but a lot of the kids in that program are first-generation college students. And so sometimes we work with people in the flags office and in admissions. And so they've come now 2 years in a row, and we put on bilingual programming. We've also done like a program over spring break. And so everything that you are saying echoes so much with our experiences in these past 2.5 years. We're like having a centralized place where we know what's already happening would be of tremendous help to new faculty in the college so that we don't have to reinvent the wheel. And and what Cynthia said, the other thing I think where we, as being in the state of Florida, where I think we can be leaders, and I think it's something that I know both Cynthia and I are interested in, and it spans both interacting with students and also developing professional development for faculty and students at UF, is I think we could do more to be pioneers in the bilingual space, especially considering how many bilingual faculty and students we have, and the fact that we're on our way to being a Hispanic serving institution. And I would volunteer to help lead some of that professional development too. One of the things I have been really thinking about and writing into a lot of my grants that have not been funded yet is this idea of providing training for our students on talking about science and doing outreach in Spanish. And so I think that's an area where we could have a really, really big impact. But yeah, like y'all are saying, I do definitely think we need more staff support in general to be able to execute a lot of these ideas. But I have to log off, so I just wanted to make sure I put it out there, some of the stuff that we are doing in the lab and some of the ideas we have. And thank you all for this space.
Yeah, I love that. I know I've talked to Idalis a lot about the bilingual space, and I think we are positioned really well to really affect multilingual programming. And I think you hit it on the nail, like when we're working with Latino families, making sure that we're working with the families to get the students because of the communal culture. We can't just go to the student and get the student to come. It needs to be a communal effort. And I know that from some of my work too. So I love we have a vast array of expertise.
Yeah, and
here
I
at
think
the college.
there's
It's
like a
just
ton of
coordinating.
overlap, right? Because we're working with schools in Colombia and Central America and also Italy. So I do think we do need to think about what our global presence is in addition to our presence within the state of Florida to support all learners in multiple languages.
Mm-hmm.
Yeah, I agree, Nancy. And I actually also work with an organization in Colombia called Science Clubs. And so we put together workshops in rural areas of Colombia. Again, so I love this space where we can all share our ideas. But in what you all were saying, like identifying grants that we can go after for K through 12 for all of these things, because it would be really cool to perhaps come up with some programs where we could maybe take our students that are developing those bilingual competencies here and take them to work in Colombia, or maybe come up with creative ways that like our K through 12 students here in Florida can maybe attend a workshop with people in other parts of the world. Anyways, there's so many things we could do, but of course we need resources to be able to execute some of these ideas.
Thank you, Anna. And thank you, Christina and Nancy, for your leading of this discussion in this area. We certainly, I could see where this could go on for several more minutes. And so maybe this will be the first of many of these sessions, and maybe we'll get specialized sessions going forward. I think this idea of the journey of a young engineer beginning with this budding engineer in the K through 12 space, where we ignite their interest and get involved in many of the areas that both Nancy, Christina, and our commenters have added to, that continues on to the next phase of an engineer's life, the novice engineer. That novice engineering space, as I introduced earlier, sort of begins, and we're thinking about this post-undergraduate or post-high school career period. Now, we showed them here on the slide as being undergrads, but this could be technical school, this could be community college, this could be whatever that training is beyond the high school years. In this novice engineer stage, we're beginning to see the scaffolding of that knowledge, the understanding of what engineers are. And for this particular phase, we have two presenters who will come before us, and that is Idalis Villanueva and Hans van Oostrom, both in our engineering education department, who will talk again about some of the programs that are happening and maybe even spark our interest in what could happen. One of the things that I think about, particularly beginning really all the way back to K through 12, is how are we looking at AI enabling learning? So this AI enhanced environments. How do we build on experiential learning for these engineers? And I do want to say for Idalis and Hans, I've enabled multiple sharing, so feel free to start sharing your slides whenever you'd like to. And the other thing with this space is, how do we help then early engineers really begin to understand this concept of even lifelong learning? This idea that learning does not stop at whether it's technical school or community college or the 4-year programming, that they have the opportunity to continue to upskill themselves, and that how can the University of Florida play a significant role in that ongoing education of an engineer. And I want to just stop really quickly because I believe, let's make sure. Idalis, are you able to share your slides?
I am sharing my slides.
You are sharing. Awesome.
Can you see it?
Thank you so very much. I think as soon as I stop, it'll be shown then. I just want to be sure that it's a smooth handoff. So yeah. A little behind the curtain. So with that, I'd like to now turn over to my colleagues who you saw was mentioned in the previous phase, Dr. Villanueva, to talk to us about the novice engineer.
Good morning. Can you hear me? Can you see the slides? I just want to make sure before we start.
Yes.
Okay, thank you. So I'm accompanied by Hans van Oostrom, and together we are presenting a little bit about the novice engineer. I really appreciated seeing the previous version and all the amazing activities and just opportunities that there and possibilities for budding engineers. I've done a little bit of work in the K through 12 space, and it's really important to do to involve the community in the process of engaging in that engineering mindset. Now, in the novice engineer stage, we're really talking about undergraduate education once they go into college. And what does that mean when we're thinking about it from a lifelong learning lens? And for this, we wanted to present a couple of overarching missions between the novice engineering stage, as well as some goals that we are currently either engaging with or exploring about the possibilities of what that would look like at a university environment. So the overarching mission is to create a transformative and accessible learning experience that sets undergraduate students on a trajectory to acquire foundational skills, knowledges, and problem-solving experiences necessary to succeed in a rapidly changing and increasingly interconnected world. Some of those goals are to create an immersive experience in undergraduate engineering education that include technological advances such as AI throughout the four-year curriculum, to maximize workforce training experiences and partnerships, for example, micro-internships, online undergraduate experiences, co-ops, etc., with industries that are leading these technological advancements, and to prepare students to have discipline-spanning mindsets, problem-solving approaches and attitudes towards technological developments that propel self-development, leadership, and entrepreneurship throughout their lives. This latter point is really important because I don't think we no longer are in these engineering silos, right? In the past, you know, if you were a chemical engineer, you were a chemical engineer all the way, but now there's more collaborations across disciplines. And so really helping students understand that it is really important to have an open mind for that is key. So I will leave you with Hans, who will discuss this section.
Yeah, so those are our goals, and so let's take a step back and look at what we currently have at UF, programs that do exist that can help us with that, and that we can expand upon. You know, the first piece of recruitment is there for two reasons. One is for recruitment into the next phase, which is you know, a graduate degree. We have quite a bit of effort here at our college doing that. But the other reason would be to see, can we use some of these techniques and processes to recruit new undergraduate students? So do this as well in the K through 12 space. So there are certainly some overlaps there. As far as a traditional sort of engineering education goes, we have our residential student experience, which is the biggest piece of what we do. These are our 12 engineering majors that students go into once they get admitted. And as Jana said, we don't have a lot of control over those admissions. So on that boundary, there's certainly a lot of work to be done. Maybe take these out of order a little bit, but there are multiple programs that help students to become engineers. So the Innovation Academy is one. We don't have a big play in that, but the Innovation Academy was created because there was excess space at UF in the spring and summer semesters, and they created a program to fill that space. And the whole purpose of that is design and innovation and creation. And engineering does not yet play a big role in that. And so there is certainly an opportunity. There are other programs, especially related to new technologies, such as AI certificates that can be obtained in sort of parallel to a traditional engineering major. There are other trainings. There are trainings that are outside of UF, skill sets, badges that, say, Google and Amazon are offering that might be beneficial. How do we incorporate these things and give students credit for that. As nobody will argue that these are important for students to get these jobs with these companies, but currently we don't encourage them. It's extra work for students. How do we even let them know what's good and what's not, and that we have a role there. So then the other pieces are sort of retention of students. We have a fairly big problem with retention. I believe our first to second year retention is somewhere around 60%, or maybe that's the overall retention in engineering. What happens with these students? Why do they not continue? We created the first year design program that is now required for almost half of our incoming students. And we taught 1,200 students in that last year. How, that shows them what engineering is, that shows them what design is, and gets them excited to do engineering. In the past, the first 3 semesters were tied up with college liberal arts and sciences courses, physics, chemistry, math, and a lot of students didn't see the relevance. And so hopefully with this, we can see some relevance. Obviously, we're a Research One university, so research is a big piece, and a lot of our students are doing research and other research experiences, bringing students from other institutions to do research with us. And then sort of another big piece, advising wellness retention. We have these services. Obviously, they're maxed out, but they are available. I think with the student success group that's coming on board, that's being revamped at the university level, this is another piece that can tie into that. And then student organizations. We always say you should join a student organization, but then it's a bit of a haphazard type of organization. There should be more structure. With the Malinowski Hall, there's now some new spaces for these groups, and so that's a great step forward, but it isn't totally solved. And then as far as hopping sort of through the program, can you do pieces online if you need to be away for a semester? We're trying to really do that for the summer semester currently, but this could be applied to others as well. And then what additional certifications or certificates or other kind of credentialing do we need to try to, make that better? I'll give you an example on the next slide about, an integrative kind of approach that mechanical engineering has been taking. And this is just an example, and it is what they've been doing for several years now, designed throughout the curriculum. Bruce Carroll has really spearheaded that. And that means that there is a design component in almost every semester, starting in semester 2. Obviously, they could take freshman design in semester 1, so you had that covered as well. Computer-aided graphics and design. There are design and manufacturing laboratory, mechanical engineering design 1, mechanical engineering design 2, and so you progress through your semester doing some design everywhere. And design is really a crucial piece of experiential learning, of hands-on learning, of skilling, and of problem solving. And so if we go back and take a step back and say, what is it that our students need? I think they need all of those things. Yes, they need a great foundation of, statics and other courses and math, but what is it really, as we all are out of school, what is it that what we use in engineering? And I think a lot of it is this design techniques and problem solving techniques. We'll go to the next slide. So here's a proposal, just again an idea for IPPD throughout the semester, throughout the career of a student. So IPPD is the interdisciplinary program and process and I forget now, a design program.
Product design.
Product. There we go. Yeah. Yes, thank you. That runs in the senior year. It's a 2-semester design with industry. very integrated with the industry problem to solve. And that has really been very beneficial. These are industry sponsored, but I think we can do more by weaving in some of these design experiences, and they can be somewhat informal through, say, research, but they could also be formalized. And so one proposal that we've been floating is to have, starting in their second year, students take some credits that where they get an industry problem that, or it could be research, or it could be more like service learning tied to Quest, for example. But they take on a problem that they can continue on for several years. We find we have a lot of problem projects in IPPD that come within a year to a great prototype, but then something else is needed, right? So it needs to be developed further. And so we put a brand new team on it and the next year, and there is not a lot of continuity there because the previous students are all gone, they've graduated. And so starting that earlier could really create much better and a longer term kind of engagement of students in design. And so this is a way to do what mechanical engineering has done and do it at a college level. So so that's just one thought of that. I'll hand it back over to you, Dallas.
Yeah, thank you. And thank you, Nancy, for acknowledging MSC's role on this as well. This is also very a similar model. I kind of wanted to add to what Iron Range Engineering is doing. And for those of you who are not familiar with that program, how that program works is that you have an industry sponsor who will hire students in their freshman or sophomore years for a 3 to 4 year contract. And they are working continuously on that project with company mentors as well as faculty mentors, and their education. There is foundational courses, but the electives that they take are tailored to helping solve the problem that they've been contracted for the next 3 years. The idea behind that is that then the student has a 3-year experience by the time they graduate, and thus can either be hired by the company based on their improvement in the project, or it gives them a leg up to be able to be hired in other companies later on. One of the things that we really need to think about when we're thinking about this particular stage of engineering education is we do a pretty decent job of getting people in, but then we're very traditional in the way that we approach their education. We assume that if a person goes through the traditional 4-year curriculum in the order and the sequence of events that we do, that they're going to graduate. But we know from literature that the attrition rates are really high for students, especially those who are non-traditional, those who are underrepresented. This pathway does not necessarily work with them. Also, we also have to think about that we may have multiple needs in that educational pathway. It might be that we have an online option, right? And whether that's an online course or a residential program or a graduate education program, there is also this inherent assumption that online education, if following the same path in that same linear fashion, will also lead to graduation. But the reality is it's much more complex, and we really need to start thinking about the ways that we can intertwine the pathways, because there is no single pathway that may fit for the student, and the needs of the students may be different. And so we need to start thinking about how do we contextualize engineering education so that they can pursue multiple pathways and make it a meaningful experience for them. At the same time, we have to recognize that as we introduce AI, as we introduce online education, or whatever new forms of engineering education arise, that it is still important to integrate those fundamentals on the students, right? And sometimes that may be lost if it is just a fully online course, because in the interest of trying to keep things short and succinct, there are certain skills and certain values that we still need to instill in that engineer at that novice stage. And so I have a question for you. And so if you have your phones with you, you can scan the QR code that you see here. I'm also going to share the link that you see in case anyone might be interested in just going online and doing that. So I just shared it with everyone. And the question is, using your phone or your computer, describe what lessons from traditional engineering education can be brought into the online space. And when I mean online, I'm including all of it, AI, VR, AR, all the other forms to encourage lifelong learning. So while you do that, I'm going to stop sharing the screen just for a second, because I want this to be a dynamic experience for all. So just 1 second, bear with me. And I'm sharing this one. Okay. All right. All right. So take a minute, scan the QR code, and let us know your thoughts on this. What lessons from traditional engineering education can be brought into newer spaces of engineering education to encourage lifelong learning? Okay, we're seeing a lot of collaboration so far. So the size of the word says the degree of importance, by the way, of what the community right now is sharing today. Okay, let's give it 1 more minute. And so I see international experiences, collaboration, problem solving, mentorship chat, troubleshooting, teamwork, application. Okay, so in the interest of time, you're welcome to continue adding to this, but I'm interested to hear from the audience, right? How do we start thinking about these intertwined pathways, right? Where students may start in one class and maybe they move on to a different class, not necessarily tied to a discipline, so that they can carve out their career path. How do we incorporate, for example, collaboration into those types of spaces? So I just want to hear from the audience right now. Feel free to just, unmute yourself and share. Or in the chat. I see some in the chat. Yeah, thank you, Sarah. Could you describe a little bit what the Kairos program is, Sarah?
Sure. Can you hear me a little bit better?
Yes.
Okay, great. Yeah, so it's called the Active Learning Program, and I believe they offer it fall, spring, and summer semesters. So it's maybe easier to access just because every semester it's available. It's something students have to apply for, so it can be maybe a little competitive, but ultimately they sign up for a course, 3-credit internship, and they get to work in a research lab, either in groups or individually. I think most commonly they're working in groups with other students who are participants of the Active Learning Program. And when you look at the Active Learning Program, at least currently, they have over 100, over 200 projects. And so I think what makes it really exciting for engineering students is they're able to look at this really long list and find something that they're really interested and motivated in. And maybe the topic isn't obviously in engineering, but there are these broader social implications with the work. And so they're still using their engineering design and engineering critical thinking that they're learning in their other courses in this more open-ended work that's still very heavily guided by faculty. So it's just a really great experiential learning opportunity.
Yeah, it sounds like a really good program. Yeah, thank you for sharing.
I've heard very good things from my students who did it, so.
Yeah, nice. Anyone else that would like to share? I think we have maybe a minute left or two.
This is Christina. I love all the information that you all shared, and I think as we do start thinking about Quest, I know from the curriculum committee standpoint, we had a meeting, I think last month, or maybe it was earlier this month. I'm losing track of time, but we were starting to begin thinking about what does Quest 3 look like, and that's about experiential learning. So the things that you're talking about, kind of like where we have IPPD for senior project, that's kind of college-wide, thinking about a college-wide kind of design experience, I think, and all the things that you're talking about are really good. So this is a really good start to a conversation.
Mm-hmm. Yeah, thank you for sharing. Hans, do you want to say something?
No, I think that's true. I think we should try to avoid having students go to Quest 3 outside of our college, because there's so much opportunity within our college to fulfill those requirements so that are upcoming. So yes, I agree.
Yeah, and there's other things that we didn't really include on this presentation, like international experiences, study abroad, and other programs, but there's definitely a lot of opportunities to make the experience very impactful for students at UF.
And I think, a thing I say often is what is that crucial part of of an engineering degree, right? How do we capture that? And sometimes we are very traditional, or we've always taught this, and we've been teaching this for 50 years. Well, let's go take a look. Is that really needed? Or can this be easily learned when you need it later? And maybe create some room in the curriculum for these other essential skills that are the skills that we actually build our career up on, right? So there needs to be a balance of that.
All right. Well, are there any other questions or comments?
I think Christina in the chat, that's a good, we should really have a list of things that would fulfill Quest 3 and work on getting those courses marked as that, because that would really allow us to keep our students within our college and have them do a relevant experience.
Yeah. And it doesn't just have to be courses. I think I was thinking about also like, what are the things, like I know with CISC, we have a lot of like hackathons and things that students can gain experience from. And I'm imagining that each one of the disciplines has their own kind of set of things that are, students in your program might know about, but we need to make that more public facing. I think a lot of times people just don't understand all the opportunities that they have when they come here.
Totally agree.
Yeah, and Alexis just shared that, perhaps considering cohorts that can be collaborative between, if I'm understanding it correctly, in-person and online spaces. So really bridging that so that there is more of a sense of community and collaboration across. So thank you for that comment, Alexis. Okay. All right. Well, if that's it, thank you for your time. We really appreciate it.
Yes, thank you.
Thank you, Adalis and Hans, for that very comprehensive sort of look of what are we doing in this sort of novice engineering space, and then what are some things that we could be doing. There is a common theme I'm sort of hearing, and it's this is definitely, I'll be listening to this recording again. There's a lot of ideas sort of bubbling up around things that might be right for a conversation now. And so if you are listening to some of the ideas that were either with Christina and Nancy or Adalis and Hans, and there's some things you want to get involved in with them or starting a group or discussion, please feel free, feel empowered to sort of move those ideas forward. I think about things at multiple levels. There's some things that are sort of, we just need to have a discussion around it till it builds to something a little more substantial. And then maybe it's moving to what, a funded grant idea? Or is it just a community sort of group moving together organically? So I think about things moving in multiple ways. So I'm hoping you're thinking similarly. So thank you again. As we transition now, going back to our model, we've sort of navigated from the budding to the novice engineer and maybe moving to this agentic phase. So our next two speakers, sets of speakers, may actually blend some phases. If you think really the budding engineer, some of that conversation began moving towards the novice engineer, and the novice was sort of looking back a little bit about what's happening in that budding phase. These transitional phases are really quite important. As we think about moving to our next 2 half-hour sessions, you're going to also see that blending occur again. And so as we move from budding engineer to novice engineer, and now maybe agentic engineers, or maybe it's an agentic and lifelong learning blend, I'd like to think about where are we in the training of an engineer? If we say that in this sort of novice phase, whether that occurs in a technical community college, 4-year institution, what we've done is an introduction to this field of engineering. When we move beyond that phase, what we're beginning to do is sort of have students beginning to maybe get work experiences, and then maybe realizing there's some strength and need for some additional skilling. Maybe this is upper education, so master's, graduate student, postdoc, as we noted here in the slide, that maybe agentic engineers are maybe graduate students. So whether they're graduate students or early career engineers, the needs sort of shift, right? So it's not yet this formation of engineering as an idea and then the initial skilling of them as engineers. They now have a little bit of experience under their belt and needing a bit more. What are we thinking here? We're thinking maybe initially about the development and creation of transfer skills, advancing mentoring connections here, maybe how training through certificate programs and other things can help scaffold that knowledge. Again, we think also about how we can rise up and enable flexibility in their learning and that. So with that, I would like to hand over to our next pair of speakers. Fernando and Sandia are going to come to speak to us about what are they thinking about really specifically agentic engineers, or perhaps the blend of agentic and lifelong learning engineers. So with that, I'd like to pass along to Fernando and Sandia.
Yes, thank you very much. Can you see my slides? All right. So thank you, Denise. Good morning, everyone. So it is a pleasure to me to be here today along with my colleague Cynthia Rivera Jimenez. And we will talk about this idea that the chemical engineering department and the engineering education department are putting together to re-envision the way how we run engineering laboratories. So we are proposing a scheme to better represent how we want to show improvements. And I think that the previous presentation was a pretty well transition to what we will discuss today, because we are taking elements from the novice engineer phase, and then we are proposing improvements for the blend of agentic engineers and lifelong engineers. So this is the idea that we have been working with, and we will be happy to share it with you. And of course, we are open to ideas and suggestions, because this is the way how we consider that this work can be made more dynamic. And Cynthia and I will be jumping over and over again, because this is how we think that it's better for us to explain our ideas. So with that, I will leave you to my colleague, Cynthia Rivera, and she will start explaining a little bit about the idea of creating a blended learning model for engineering students. Cynthia, are you there?
Can you hear me now?
Yes.
Okay, thank you. So I think this is a really great transition, because I think Idala's and Hans' question about what should be bringing to online spaces is a really overwhelming answer, because there's so many aspects on what to bring and the context of the class and the level of the student. I think all of that contextualization is important. So when you want to transform classes that are traditionally face-to-face into completely online. So what we're gonna do with our project is actually systematically analyze and transform a course, which is a laboratory course that has its own challenges, from a technology enhanced course to a mostly online course, with the vision that we learn how to create instructional design environments that allow us to understand if the students are meeting the learning outcomes in the class. Okay, so before we proceed, I want you to see what is the differences between traditional face-to-face to completely online. There are multiple definitions about what is remote learning. So I just wanted to contextualize, right, that we're talking about classes that are technology enhanced, that they're typically face-to-face, but they do have some sort of like technology like Canvas, or they have videos, or they have things that involve technology. And then as we move forward to the right side from blended to mostly online, what we see is a reduction of the face-to-face time to have more online content, and that can be synchronous and asynchronous. So we're not going to go into the details of that type of format, but we just want you to see, right, that the literature does says that there's some transferable skills that remote learning builds. So some of them, right, involve time management, especially when you're working in teams and collaboration, digital literacy, problem-solving skills, work-life balance, and online communication. And it's so important that we're even having this conversation online. So it's important for our students to have that. Can you please click next? But we do understand that there's some big challenges that we need to address, right? So first is assessing the ability of these virtual modalities, right, to impart knowledge and skills equivalent to those acquired in traditional face-to-face laboratory environments. Again, laboratory has a specific context compared to a regular lecture or a capstone design group, right? Laboratory environment has specific objectives that are tactile. And then the other part is equipping faculty and programs to be able to have the appropriate instructional techniques to teach in multiple, right, delivery system simultaneously, right? So it is a big challenge to do so. Can you click next? So before we tell you what we're going to do, we want to talk to you about the story about how this project came off. So in 2020, we have the emergency remote teaching phenomenon, right? We all have to convert our classes online. And I just want you to see the list of learning outcomes of our class. If you click next, okay. I want to point out that emergency remote teaching is not online teaching. Remote emergency teaching was a response that we had that was on plan and on previously designed learning environments that we have to react, right, given the circumstances that we have. What we're talking about is like instructional design that is evidence-based practice, and it's actually like looking into the theories and things like that to actually implement them. Fernando.
Yes, so we are showing pictures here of how our one of chemical engineering laboratories is. So we have pilot scale experimentation in which students learn how to operate evaporators, distillation columns, continuous filtration systems. So when we were forced to move online in spring 2020, we were wondering, how is it possible that we will be able to teach laboratory courses online while keeping the hands-on experience and other student learning outcomes? So that's when, like my colleague Cynthia mentioned before, we had this emergency remote teaching, and we had to find out, react, right? And that was the moment when a team of faculty members in the chemical engineering department started to brainstorm on how are we doing this. And we put together a lot of ideas. It was an interesting summer, and we designed desk scale experimental kits to teach the first of the chemical engineering laboratories. So the idea was that each student could have one set of experimental kits to develop their experiments online with remote assistance. And these kits should be modular, modern, versatile, easy to ship, and more importantly, at low cost, right? Because we didn't want to affect the student because of this emergency. So we put together different kits, which these kits had as the main heart of the kit was 3D printed process units. And then we combined other flow elements like small pumps, flexible tubing, and then we worked with sensors that work with Arduino microprocessors, such that students could have the same experience that they have in a pilot scale laboratory in terms of the fundamentals behind experiments, in terms of the concepts that they were using behind these experiments. And as you can see here, this is an example of the mini fluid flow kit that students were using one semester fully online, and then for a second semester with a high flex platform. And this is an actual picture of how the mini fluidic device looks like with pipes of different diameters and different orientations. And this is just an example of different kits that we put together for students. So even though this was really fast, and we had only the summer 2020 to work with this, we are very proud to show or to showcase our products. So at the educational level, we were able to have 4 different experimental kits: fluid flowing pipes, pump and valve curves, fixed bed columns, and heat exchangers. So these were the experiments that students were conducting fully online with only remote assistance. And then after this, we noticed that this was also material to have other products in terms of dissemination. So we are presenting here a short list of how we have been disseminating our efforts to hold a laboratory course online. But remember, this is from the perspective of the experience that we had in 2020 because of this emergency remote teaching, right? So we have presented our work in different conferences. We have conference proceedings. We have now a seed funding from the College of Engineering. We are working in a proposal, and Cynthia will provide you with more details later today. And at this moment, we have at least 2 potential collaborators in other institutions. And this will cover other areas like outreach, but we will start first describing what exactly is our objective here. So as you can see, this is a good strategy to pair the chemical engineering department and the engineering education departments, because we want to foster the ability to have laboratory courses online, but applying the theory of blended learning.
So one of the things is that when the emergency stopped, we went back to technology enhanced. So what Fernando did really well was incorporating the kits to scaffold students' knowledge to learn the phenomena in the kits, working with the kits, and then they spend some time in the lab doing the scale up. And I want to point out that when we're talking about chemical engineering labs, I'm not talking about a chemistry lab. These are large scale instruments, 20 feet, 10 feet distillation columns, heat exchangers, which is a challenge too for other disciplines like mechanical engineering, right? They need to have that tactile experience with industry-like equipment. So he was able to incorporate it. However, can you click again? So again, emergency remote teaching is not the same as quality teaching. So the goal for this project is to understand, right, what do we need to do to get this this laboratory experience in something that is mostly online and completely online. So to do so, we are proposing two goals. Can you click again? So one is to understand how we can effectively design blended learning experiences for engineering laboratories. Notice that this is very broad because, again, there's other disciplines like mechanical engineering that can learn from the experience that we're building, and hopefully we can work with people from mechanical engineering. And we are trying to focus not only on the specific learning outcomes, but also on enhance students' lifelong learning skills. And then the other part is the strategies. What type of critical strategies we can foster in a class like this that can address the critical challenges in online engineering laboratory courses. Can you click again?
And yes, like Cynthia mentioned before, after we resumed to in-person laboratories, yes, we were able to still use some of our kits because we noticed how important is for students the concept of scaling up and scaling down processes. So after 4 or 5 semesters of having laboratories now with combined skills of experimentation, we're proud of it and students are really liking it. So now our question is, can we redesign again an online laboratory course, but now making sure that we are not following the emergency nature of this transition again? So those are our questions. And we are showing here again the lifelong learning diagram to help you to situate where our project is specifically located. So as I mentioned at the beginning of this talk, we are taking elements from the novice engineer phase, and we are using these elements to describe how is our idea to have a better formation of agentic engineers, but with the idea that our students, they keep a lifelong learning experience and they can use that in the profession. Okay, so I think that aiming to contribute with this idea, essentially what we are suggesting now is the design of a blended laboratory. Now that we notice that we can use that in the lab in person with combined scales of experimentation that better prepares students to go to the field, which by the way, these 2 pictures are students from our chemical engineering department. So we are suggesting staying in this area here, taking elements from this phase, novice engineers, and then what are the outcomes, what the goals are to contribute to the other phases according to this diagram. And this is exactly what we are gonna share with you now, what our ideas are, what our expected outcomes are. And what we are suggesting is an 8-week pilot study to be conducted over summer 2024. And I will let my colleague Cynthia to talk about our ideas for the participants and the instructional design. And then I will talk about the proposed schedule for an 8-week time window.
Yeah, so one of the things that we are trying to address, one of the biggest problems is that many of the students in chemical engineering, they do co-ops and they do internships and they do study abroad. So we want to design an equivalent experience for those students where they can actually learn, right, how to do this type of tactile experiences as they are also completing these requirements, right, of doing co-ops and internships. So what we're going to do is that we're going to pilot like a mini version, an 8-week version of potentially a full course that is 16 weeks. So initially, what the seed funding is sponsoring is actually the participants. So we're not going to have any credits. It's going to be just a pilot. We're going to have an IRB in place because we're going to be collecting data on the student experience. We're going to have recruit 12 students. These are 3 teams, right? We're going to have peer tutors and we're going to have a graduate student. And all of those are going to help to mimic the environment, right, of the classroom. And then we're going to have some instructional design materials, right, that we have inherited from the COVID era and what Fernando does in his class, right? Team building activities. We're going to have data analysis topics. We're going to have content related to report preparation. We're going to have also reflective practices to see how the student, what are the challenges and experiences of the students in the process. We're going to also have kits for the students, and we're going to have like this collaborative environment to be tested throughout the whole pilot. And Fernando.
Yes, and the proposed schedule, like I mentioned before, is an 8-week time window in which the 75% of the time students will be collaborating online. And quickly, we have 1 week for student preparation, orientation, use of technology, team formation. From weeks 2 to 5, teams will be conducting 2 different experimental modules with 1 week for experimentation and 1 week for data analysis and report preparation. Then on week 6 and 7, they will do a similar experimentation, but that will be the in-person component. 1 week in person, and then a 2nd week for data analysis for results that collected from in-person experimentation. And then the 8th week will be used for wrapping up, to organize student presentations, and to collect feedback from final surveys. And as you can see, we are having elements that will foster the ability of students to keep communicating both written and also verbally by means of presentations. Okay, so this is the idea that we have for our study. And now we will talk about what are we expecting to see, and later on the challenges that we can anticipate for.
As I mentioned, right, we're trying to bring those Novice engineering skills and help them do a transition to our more autonomous years, right? So the idea is that we're gonna, by specifically and strategically and using theory to design successful blended and mostly online environments, we can help the students to keep engaged and sustain interest, right, in the discipline, master subjects. And the other thing is reduce the learning curve of being exposed on a blended or mostly online environment because it's so well designed. We are looking to see through the engagement and the presence of social presence, the teaching presence in the learning present. We are thinking about, you know, how we can develop knowledge creation and transferable skills that I mentioned before that are really important for employability, the development of mentoring skills. Remember that we also have peer mentors. So peer mentors are going to be trained on how to manage all of this also online. You know, and of course, building professional networks in this environment, which is kind of challenging. So if you click again, Fernando, I want you to situate how impactful this could be through the learning model, right? We're looking at students, helping students, right, between internship, co-op, studies abroad, and we are also in between. The students are going to have a traditional experience. And this is important because whatever we learn with this can be incorporated in the traditional learning experience, because the idea is that we can identify what aspects of teaching online can be measured using, you know, data-driven predictive learning analytics. We can help students that are at risk in the classes. We can actually create a model that allows people that want to replicate this in their classes to have, you know, the right research, right, to back up, right, the decisions that they make in the design of their learning environment. Again, and this is thinking about sustainability and scalability. We have people in Texas and we have people in other states that are really interested on doing this too. So there's potential for collaborations not only here at UF, but also outside. Next. I want to make sure we have 2 more minutes, Fernando, to finish this.
Yeah. Yes, and like I mentioned before, we are anticipating to some challenges, right? Because not everything can be, oh, this is going to work. So we do need to be aware of what could go wrong and having solutions or alternatives to mitigate or to prevent these challenges. So thinking about that ensuring that we have the right instructional design and that it aligns with the specific student learning outcomes. We need to make sure that we keep teamwork, independent experimental work, ability to troubleshoot, safety, and communication. Another challenge could be decreased motivation and engagement from students, and we are planning to train students on online collaboratory platforms, especially during the first week, train peer tutors, like Cynthia mentioned before, reinforce the use of technology because they will be working online. So we have to be up to date with technology and having students being part of this, and addressing student concerns throughout the program by running periodical reflections.
Yeah. And again, I just want to make sure that I'm conscious with the time and we have time to discuss. I think this aligns very well with the idea of, many of our chemistry students, they take the freshman design course and there's no connection in our curriculum to freshman design, and they're learning how to do makerspace skills. So this gives the opportunity to have those connections throughout the curriculum, and actually that makes sense, right? Because we are afraid that we're losing them in freshman design, but now we are kind of like saying, like, no, we also do this in chemical engineering. So it makes more sense, right, for them and their workforce development at UF. So Denise, this is it. Right on time.
I appreciate the efficiency as well, always. But one of the comments, one of the comments I want to make specifically as we transition to the Q&A period with Fernando and Cynthia, is that I hope you're hearing the energy and the intentionality in which this pair of speakers, but all of our speakers, are bringing to the examples. A couple of points that I want to bring out with this particular session is that intentional focus on what the student needs, the student experience, and enriching that experience. This sort of separation of what we do online in an emergency setting and what's sort of intentional when we think about what's effective teaching. Also, I think on one of the earlier slides, and some of our other presenters have talked about the same, is the multiple levels of support that could be available for advancing these ideas. And what Cynthia and Fernando specifically mentioned was the strategic funds that are available. So some of the earlier comments were around, we need support from, I'll say, the college, or I'm going to say somewhere else. And I want to say sometimes there's multiple places where that support can come from. Certainly we're in this era of looking at funds strategically, whether this is seed funding that's available at the university level, whether it's available at the college level and accessible there, whether it's available externally as an eager or, and I'm speaking NSF language, there are multiple ways. So I like, there's a threading here, but I like the focus being specifically what Cynthia and Fernando has brought to us, is an intentional focus on improving learning in a particular area. So thank you for that. And I've been watching the chat. I don't see a specific question yet, but I'll sort of be quiet here. And if you have a question or comment for these pair of speakers, please insert those now.
And so in the meantime that we have any question, I just want to point out that because we already had an experience for 2 semesters being online, we have a lot of learned lessons that now we can use to better design this pilot study. And of course, this pilot study will be just something that we can used to collect more feedback before incorporating these as a formal or as an official educational platform in the near future.
I wonder if either of you could talk about the experience or the encouragement as a viable opportunity for funding to pursue through strategic funds, since this is sort of one new area that's been open to us in the college as well as university-wide. Are you able to speak just maybe at a very high level on your experience and maybe advice or encouragement for others who might be wanting to think about pursuing that?
Like this type of funding that the college is giving us? Yeah. So I think this type of funding is really important. Also, the College of Education has similar Catalyst funds, and I think are really crucial to build capacity. So all of the data that we're going to be collecting will serve to do collaborative proposals. So we're going to focus at UF. We're going to have experiences we have a lot of Latinx students that are in the Department of Chemical Engineering and underrepresented minorities. So we're going to also focus on their experiences. And we know that it's going to spin off. Like the funding that you're giving us for the next semester will culminate in something that will spin off in something that I can envision to be multi-institutional, multi-departmental, just because the thing is that NSF doesn't give you the programmatic money, right? So this is more programmatic, but then we're going to be doing more in terms of the research aspects of blended technology or blended learning for laboratory experiences that are really unique. I want to point out that laboratories, not the capstone design, laboratories are not regular lectures. And again, the problem that we have, that scale of the labs that we have to take. So I will say that this type of opportunities are really, really important. Not only for the teaching aspect, but also for the research component of it. And yeah, I don't know if you want to say, Fernando, anything else, but I think it's been really good.
Yeah, I would just like to close this because I know that we are out of time, but we are presenting this idea for chemical engineering laboratories, but the idea is to use this platform to do the same thing for other engineering laboratories. So we are starting with our own experience at the chemical engineering department, but we can really adapt this to other departments as well.
I appreciate your timeliness. There was Sarah's put a question in, so maybe final question. So Sarah says, have you seen impacts on student performance in their later classes?
I think that, yes, we have seen how this can positively impact students in their subsequent classes. The class that students take with me is the first of the sequence, and then they take the second lab, right? So even though in the second lab, they are not working with kits in combination with pilot scale equipment, they do some work with semiconductor materials, which is also small scale. So I think that students like the idea, and we have seen improvements on their understanding on how engineers can work with different scales of experimentation, either to scale up or to scale down processes. So I think that this is one of the mechanisms that we have to track that, yes, we have positively impacted the performance of students in subsequent classes.
Well, thank you. And as I've said with the previous sessions, as we end this phase and maybe go to the next, the final speaker, this is not the last time we will have an opportunity to have a conversation. I appreciate the time and that Cindy and Fernando has both invested in not just doing this work, but having this conversation with us so that it spurs additional ideas. So thank you so very much. You know, I'm going to continue with this idea that on the lifelong learning model, these phases aren't always sort of distinct. If you think about the kind of learning that Cyndia and Fernando are trying to inspire through this lab-based class, I think it begins to open up and change this traditional way of training engineers to sort of think beyond and using sort of innovation. I think it's one of the key things that might permeate throughout all of the phases and continue and help to boost our engineers that make engineers graduating from the University of Florida different in their preparation and their ability to be sort of self-driven. I want to continue in this period of thinking about this period of development for engineers from this agentic and lifelong period, that this early career engineers into late stage career, that we certainly are wanting the infusion and involvement of industry throughout, that this becomes even more and more sort of integrated as someone sort of advances in their career, that these late stages certainly involve sharing with industry, collaborations with industry and academia, and be that through research and or practical experiences. The emphasis on self-driven research collaboration, knowledge sharing serves as sort of this beacon of future education, and is a nice tie-in to our next presenter. Trey Womack has been intentionally working in this space of extending our reach with industry into research and in different sorts of ways, so that our engineers do have this sort of different experience. And now, as I sort of transition to Trey, what he'll speak again is about this blended phase of an engineer, agentic lifelong learning. And again, this idea of where are they in their phase? It is in this either early, it could be early stage career, it could be middle stage, it could even be late stage engineer, and including it could be in this graduate student preparation. So with that, I will turn over to Trey, who will have some comments around this phase of agentic and lifelong learning engineering. Trey?
Well, first off, I want to thank you, Denise, for the opportunity to present to you all within this town hall on today. I just want to be sure that you can everyone see my screen here?
Yes.
Perfect. So as Denise mentioned, I want to give context to a couple of different things as to when I started to where we are now. I'm still newer, during my time here at the University of Florida, but I started right in wake of the pandemic under our former administration, under Dean Abernathy. And one of the things that she wanted to ensure in wake of the pandemic was that industry still had access to our undergraduate student talent pipeline. Coming from a former staffing background where I worked for a large global staffing firm, I guess my expertise lended itself well to initiate said program. From there, it's kind of scaled a little bit to now where we're thinking about how do we better engage industry for sponsored research. But one of the things that I do want to highlight is under that former administration, where there was Flux Station under the direction of Eric Sander and Dr. Kim Jacobs, one of the things that we stressed and collaborated with a lot of folks who are on this call today, some folks like Dr. Christina Gardner-McCune, Dr. Nancy Rizicki, as well as Dr. Cindia, we talked a lot about curriculum having an influence from industry. I can remember when we started to unveil the framework for a K-12 AI curriculum. One of the first things that we initiated was an industry-based survey to understand the skill sets that industry was going to prioritize in the next 5 years. And that's where we kind of coined this phrase, so to speak, of K to Gray. when you think about the workforce development or a lifelong learning model, I think that we have to think about it in a continuum phase. One of the things that I think about is, more so on the front end with K-12, that's kind of the birthing of a purpose. By the time you get to the end of the curriculum, what we're calling like the agentic or lifelong learning phase, that's kind of purpose reimagined. So one of the things that I wanted to stress is that I will kind of harp on the thoughts of industry, what the data has to say about it, but also keeping in mind the importance of purpose birth at the K-12 phase, going on through the technical phase where you're really gathering the tactics and techniques that's necessary to be successful, but also understanding that there will come a phase in the career where now you're thinking about purpose reimagined. So with that, I want to go to my next slide. So where is industry now, right? I think that I'm going to have more of an industry perspective due to the fact that that's whom I'm spending most of my time engaging with, and more so being like a liaison between the college and what industry needs, and trying to see where we fit and how we can find synergies and alignment that come together. So where's industry now? One thing that we have to pay attention to, I think, is our students and what they're saying. I think that there are many different perspectives in higher ed. There's one that focuses on higher ed more so being about budding innovation and research. The other side of it is understanding that students are why we're here, right? So I think that understanding what students are saying and understanding what industry is saying is very important to the lifelong learning model. So what are a couple of things that I found in research? I found that 42% of students prefer a hybrid work model. As I talk, we'll understand why this is more important. We understand that this modality makes up 45% of all new hires. And then when we focus on like career starting, or we focus on undergrads or more so graduate students or doctoral students now entering the workforce from a standpoint of, going into industry, we understand that all entry-level hiring makes up, this modality of hybrid makes up 48% of that demographic. So why is that important? It's important to understand that when the pandemic hit, it kind of shifted the perspective of the modality that was most important. At the beginning, prior to the pandemic, in person was important. But I think as we moved on, we understand that more of the hybrid model is important, which then also gives, I would say, gives more look into how we frame our lifelong learning model, understanding the modality that makes sense, number one, to students, but also makes sense to industry. Okay, so what else is industry saying? We understand that now in the past, right, there might have been a different look into a student that had an online degree versus an actual on-campus in-person degree. But I think that the pandemic has shifted that thinking. One of the things that I often lean to when it comes to just my perspective towards online degrees, I can remember being with Dean Abernathy at one point down in the Space Coast when we were visiting with some of our stakeholders down there. And she received the question when she opened up the floor of, where do you see higher ed going in the next 20 years? And I'll never forget what she said. One of the things that she said is, at that point, gone are going to be the days of the Henry Ford production model of slamming as many students as we can through this assembly line in preparation for industry. We have to rethink and reimagine how we go about educating the next generation. And I think it shows up here in the data. It shows up here where 87.4% of new grads had online degrees. This is coming, all of this data on this page is coming from NACE, which happens to be the National Association of Collegiate and Employers. So now you have higher ed and employers and industry coming together to take surveys to see how the outlook for jobs in the current year is transforming. And this data that they collected, they actually found out that 87.4% of new grads actually had online degrees. So now what we're beginning to understand is that online degrees have as much weight as in person. What is another thing that we're beginning to see? That GPAs aren't being weighted as heavy in the interviewing process. We're understanding that skills, competencies, and attributes are being weighed just as heavy. I think that we've heard these types of reports from our Dean's External Advisory Board, but we also have begun to implement these in different forms of our curriculum. And what we understand is that some of the top rated career readiness competencies continue to be communication, continue to be teamwork, critical thinking, and problem solving. So how does a Gator separate themselves from the rest of the marketplace of other institutions? I think what I've begun to hear from industry is the reason why they come down here to the Southeast, to Florida, to recruit our students is because our engineers are the best all-arounders you will find based off of any other institution, right? When I say all-arounders, what that means is that a lot of our students, because of our diverse array of student organizations and student-led design teams, what we find is that a lot of our students communicate well on various levels. They have worked in teams and they've had to think critically about solving problems. So, you know, from a foundational level on the technical readiness side of things to more of the applied side of things, our students are more adaptable and flexible when it now comes to applying things because of things like internships and actual capstone projects that have come through sponsored research, where they now have the experience that is necessary to go into industry and be successful. So I think that that is a part of what we need to consider as we move forward with the lifelong learning model, but especially here closer to the backside of things where our undergrads, grads, or PhD students are now entering industry, even on to those who are in the current workforce. Where is industry headed? So what I want us to pay attention to here is a couple of things. When you look at 2018, and again, this particular data comes from NACE. When you look at 2018, and then you look at 2021, and you look at 2024, what we understand is that there is kind of like this recalculation where there's a dip, but then there is this rapid rate of growth. One of the things I'm reminded of in our recent DAB meeting was when Dean Masters was talking, he talked about these dials, and he was more so talking about dials with reference to ratings and understanding what certain dials we need to turn up. I think that what we have to understand is there has to be multiple approaches to how we just approach lifelong learning. What we have to understand is that, yes, there's an approach for workforce development for those who are currently in industry and working, but there's also the dial of K-12, and there's the dial of current students that are here at the institution now. What we have to understand is that because of this data, there comes different times and seasons where you will have to turn one dial more than the other. So here in this data we see in 2018, this would have been the perfect time to focus on the current workforce. One of the things that I often think about, and we'll touch on here in the next few slides, is the recession of 2008, right? I think that, depending on who you talk to, what economist it is, a lot of them would agree and some disagree that we're actually in a recession right now. I think that this particular report definitely begins to show the impacts of some sort of recalculation of our economic system, with the fact that because of this fall, there's actually a negative 2% decrease when we see the actual job growth projections, right? As pertaining to all skill sets, not just engineering, but we're focusing on all skill sets right now. I think these are moments where the dial for workforce development in the current workforce need to be turned up. Let me say it again. The folks that's in industry right now, we need to focus on how do we help them? How do we upskill them? How do we better prepare them for where industry and the marketplace is headed? And there's a couple of different things. I can remember when I first started in Flex Station, we talked about the fifth industrial revolution. We were talking about AI. We were talking about automation. Now these sorts of things are beginning to show up in industry, and it's starting to be at a place where the current workforce needs to be upskilled. So I think this graphic here shows that we need to turn up that dial and are connecting with industry to focus on those who are currently in the workforce. So what does this mean for engineering, right? Because this particular graphic focuses on all, but when you look further in the NACE report, what you will see is that social services, engineering services, and construction are still committed to increasing hiring. These particular skill sets, particularly engineering, even in times of recession, will continue to hire. And I'm going to touch on why as we go further in the presentation. One thing I want to look at here is the national average when it looks at job growth in comparison to the state of Florida, right? I want us to pay attention to this here because I think as we think about the lifelong model, we need to, as was said in the portion of the presentation before me, think about the intentionality of focus, right? And pertaining to more so with this part of the presentation of who is the targeted demographic that we're trying to be most impactful with, especially in this continuum approach. So what we see here is that the state of Florida is growing at a faster clip than the national average. And in this particular survey, I used a platform called Lightcast. It was formerly MZ. And what I did was I put in all the standard occupational codes that is associated with the various departments that we have here at the Herbert Wertheim College of Engineering. So with these particular skill sets nationally, the black part of the graph shows the growth track by which the national average is growing. But when you focus on the blue track, it shows more so the growth track of the state of Florida. And what we see that the state of Florida, the projection is by 2023, which this goes back from 2008 to 2023, we understand that the projected growth track is for it to almost double. But one thing that really piqued my interest when I ran this report was the fact of focusing on this continuum and focusing on the retirement age, which is more so like purpose reimagined. This retirement age is like a big number of the workforce. In actuality, if I was to pull up where from the report that I ran, where early career starters were, it was almost equal, but it was a little bit unbalanced because what we would have seen was that the retirement side of things was slightly higher. I think that this is a demographic that has to be approached where we figure out ways to get them to come back into the lifelong learning model to educate, because now they have been in industry for such a long time that they have the perspective of application and they are closer to it from a standpoint of just retiring. So I think that there's a side where we need to reconsider keeping this continuum wheel going so that those who are then going to enter the workforce are further nurtured and ready for where industry is headed. So one of the things that I wanted to do was get a little bit more granular, and I wanted to focus on actually the state of Florida versus the Gainesville region. And I looked at industry's jobs growth. And one of the things that came to mind when I was thinking of this was the land grant mission. More so thinking about how we are to bolster and sustain economic prosperity for the state of Florida. One of the things that I was looking for was, as it pertains to job growth, where does the state of Florida show up, but then where does Gainesville show up? So what I did here with this particular survey was I included every county in the state of Florida, but then I broke it out where we use the MSA code for the Gainesville region. And what we will see is that there are a couple of different areas where we see things that are coinciding. What we see is that manufacturing is one of the areas that are in both graphs up pretty high. Also, we see healthcare and social assistance as one of those areas. And one of the things that I was understanding from a recent visit prior to Thanksgiving break was I had a chance to visit a Walmart distribution center who happens to service the North region and the Western regions of Florida and all of Puerto Rico. And one of the things that they told me is that they want to partner with us because they plan to automate their entire distribution center. Think about the implications of automating their entire distribution center. What does that mean for the current workforce, which they currently employ right under 1,000 employees within this distribution center? That's a huge demographic that is going to need upskilling as it pertains to automation, which when you think about manufacturing in general, we now have additive manufacturing. And I don't think it's by mistake that here in the state of Florida and in the Gainesville region, we see manufacturing being amongst the top. But one of the areas that I think is critical for us to consider is manufacturing. And with us now having the fastest supercomputer and all of these different things pertaining to subject matter experts with AI, how can we be a resource to the current workforce, the more so lifelong learners that are going to have purpose reimagined, as well as our students that's going to now be coming into an environment where AI and additive manufacturing is heavy. So here are a few things to consider as I close. I know we have a question and answering section, but these are a couple things that came to mind that I wanted us to ponder on. And it's kind of rhetorical, and maybe we can expand upon it as we go into the question or comment section of the presentation, which is actually the next slide. But one of the things that I wanted us to think about is how significant is industry to our lifelong learning model approach, right? What does AI and automation play in the future of the top growing industries that we just seen on the previous slide? Another thing that I want us to think about is how is UF as an institution positioned to have impact on this area? Within that positioning, what role does the Herbert Wertheim College of Engineering play? Another thing that is, I want us to think about context in history, right? Because we formerly did EDGE under Dr. David Mazik, which was more so focused on DoD types of applications within the same vein. But what worked well then, right? What challenges did we face then? Is this continuum approach the answer? And then more strategically, who, what, and where is the target? We've talked about the national average. We've talked about the state of Florida. We've talked about here in the Gainesville region. But who are we trying to serve? I think that we have to be careful about trying to be the answers to all things for all people, and more so think about being a strategic solution and being the best of the best when it comes to who we're targeting. That's just my perspective and what I think the data shows. But moving on, wanted to see if there was any questions or comments with regards to the data that we just seen and just some of the perspectives and context from my time being here over the last 3 years.
Thank you, Trey. With that, I'll open for questions.
Hi, Trey. It's good to see you. Thank you
Good to
for this extensive report. I think it gives us a lot to think about. One of the questions that I was thinking about was just that number of like people getting new hires coming from like 89% of them being online programs. Is this graduate new hires or is this undergraduate new hires? Because that just seems really high. Like I feel like then nobody at you know, brick and mortar universities are actually getting hired. So I just wanted some clarification on that number.
Right. So this is a combination of all. When I looked into like that NACE job outlook, which I can share that document with you, it took into consideration a couple of things. It's institutions responding and it's employers responding, but this is all folks who are a part of this association. But what we have to look at from just this small microcosm of everything is that this report has been pretty much dead spot on when it comes to other reports with regards to their projections. So this is not just like undergrads, graduates, this is all of them being combined in one.
Yeah, because I think there's probably a different perception of an undergraduate online program than a
Yes.
graduate online program, and just wanting some clarity there. And I think whenever you do share the report, hopefully it'll let us know who was queried in
Yes.
that, because I think it also might be industry specific there too.
Right.
But yeah, I think my brain is still reeling on all of this information. I think this has been a great summit, but I think you have some good points about how do we want to position ourselves. I love that you're meeting with the companies. And I think there's a big part of how do we get ahead of it? Like, how do we make sure we have you and other people still out there kind of beating the bushes to find out what changes are coming so we can prepare for it, versus us kind of being more reactive. I love taking a proactive leadership stance on this. So thanks.
Yeah, I think I'll add a comment to that. I think one of the things that triggered that positioning of where UF is, a mentor of mine that actually turns out to be more so a minister. One of the things that he said that really boggled my mind, and I've kind of used this in various different perspectives and things that I'm doing. He said that what happens when our placement isn't where we expect to be. And he said that you have to be productive in your placement. It's one of the things that changed my mind, because often, right, if we even go back to what President Sass said at the state of, at his address to the faculty senate, one of the things he was talking about our ratings, and he was focused on comparing us to Texas Austin. And he talked about suburban sprawl versus us being rural, and historically a rural located school has not climbed the rankings like we have, and we can't expect to jump that much higher. One of the things that came to mind was, okay, with our current placement, understanding that we're rural, how can we still have the necessary impact that we need to have? And as I've come into the role where we're focusing more on industry-sponsored research, one of the things that I began to focus on is that industry is coming to us. But I don't know if where we're placed, if we've ever hung or placed a flag on saying, hey, we are the flagship for this. You may go to Georgia Tech for that, right? You may go to MIT for that, but you come to the University of Florida for that. So I think in our lifelong learning model, we have to understand where we're best placed to be the best resource for a certain vein, because other institutions have done it and they've been successful. I've been talking to Vanderbilt, Minnesota, Ohio State, a couple of other institutions that we have coined to do this pretty well, and even Georgia Tech. And it's because they figured out what areas that they do the best at that nobody else can do.
Thanks.
Well, this has been, so Trey, thank you for this thoughtful engagement and discussion of this integration of industry, and particularly the infusing of data to kind of help us think about how are we sort of looking ahead and trying to stay ahead. Sort of related to Christina's question, I sort of wondered, would somebody answer yes, even if they had a portion of their education online? So I wonder about, what does that look like? Because we're thinking about not entire online undergraduate degrees, but for maybe a portion of that could be useful. So I do wonder if peeking behind the data, is that sort of it, right? Have you had any of your courses online?
Right.
But I like it. It's definitely a provocative statistic. So, and so thank you. I think this is the first of many. I've been reading, most of the comments have been coming publicly, so you've been seeing it as well. I've been getting a couple of private messages saying just how much the community, our college, is appreciating this. I think it certainly will be maybe the first of a few things that we might do around this. As I close out, I think together, first, I want to thank all of my speakers who are listed here on the slide, punctuated and ending very well with Trey. Together, these stages form a progressive, we hope, and adaptive path, guiding learners from their early exploration into engineering through lifelong learning, innovation, and growth. The model thrives on collaboration, collaboration of multiple entities, technology integration, flexibility, continuous improvement, positioning as it relates to a vital roadmap for the future of engineering education. And if you take apart each one of those pieces that I just said, no one person can ensure that vision is going to be achieved. So this is the first part of letting the larger college community know what we're doing. But I hope there's going to be some infusion of energy to help push towards us. Whether a novice engineer or a seasoned professional, the journey through these stages offers an enriching and empowering experience that resonates with the dynamic landscape and modern engineering that the University of Florida hopes to be a leading thought producer of these types of engineers, these types of learning experiences. We can only do that with your help. So thank you for your attention. Look forward to maybe me tapping a few of you. If you want to tap a few of me, that's perfectly fine. Next on the horizon, we'll be hiring in my office, my initial hire, someone who's going to be helping me at a director's level, maybe begin to untangle and work with you strategically in pushing some of these ideas forward. So look more to that in the first of the year. As each of you end the semester, I wish you well with your semester ending tasks and a safe and productive season ahead as we head towards winter break. Thank you again for your attendance. And these materials will be made available to you, all slides as well as the recording. Thank you again. Be well.